Hi everyone, in this video I'll talk about the frame transmission model that is used in the communication system. We'll look into the error-free transmission and the transmission with error and losses, and then how do we address these issues using the flow control mechanism. We'll look into stop and wait and sliding window flow control mechanisms. To begin with, let's look at the error-free transmission model. Here where here a source sends data frames to the destination. These vertical lines, it represents the time, and these lines with the arrowhead, it represents data frame sent from source to the destination. Here the first frame is sent to the destination and is received successfully by the destination. Similarly, the frame 2, frame 3, frame 4 and frame 5 are sent by the source and are received successfully by the destination. Here all the frames are received successfully and there is no error. However, in the figure on the right, source sends a frame 1 to the destination and is well received by the destination. Source again sends the frame 2. This frame is never received by the destination. It is lost in the way. Source sends the frame 3. It is received successfully by the destination. Frame 4 sent by the source is received by the destination. However, the received frame has some error in it. And then frame 5, it is received successfully by the destination. So in this model, there are some errors and losses in the transmission. So how do we uh, address to this issue? We can address to this issue using the flow control mechanism. So when we have the flow control mechanism in the transmission system, it prevents from the receiving entity from being overwhelmed by the uh, frame sent from the source. So it prevents the buffer overflow at the destination. So to implement this, we have stop and wait flow control and sliding window flow control. So this flow control is used in the transport layer of TCP/IP protocol suite. Example in the TCP, transmission control protocol. So stop and wait flow control, it is a simplest form of flow control mechanism where the source sends a frame, and then upon receiving the frame sent by the source, destination, it sends an acknowledgement to the source indicating that it has already received the frame sent by the source. So before sending another frame, source, it waits for acknowledgement from the destination. So if a destination doesn't want to uh, receive any more frame, then it can stop it by not sending the acknowledgement back to the source. So without getting an acknowledgement from the destination, source cannot send frames any further. So this mechanism, it works well for a few large frames, but not for many. And this kind of flow control may be uh, necessary for the low quality link, because um, if the flow control mechanism is not there, there might have a high error rate. But then the limitation of this flow stop and wait flow control is um, source, it needs to wait for acknowledgement from the destination or the receiver. So when the link length is long, then it takes longer time for the uh, source to receive the acknowledgement back from the receiver. So source has to keep on waiting for a longer time to get the acknowledgement. So that will result in inefficient link utilization. Another thing is when the data rate of the link is high, and then it has to wait for the acknowledgement back from the destination, the capacity or the resource of the link is wasted. So this is not that efficient mechanism. Another thing in stop and wait flow control is the fragmentation. So fragmentation of the data is done when when the data is sent from source to the destination. It means source is going to break a large block of data into a smaller frames. So the benefit of that is when the receiver has a smaller buffer, then it can store that smaller frames easily, and also it helps in faster detection of an error if there is any error, because the receiver only has to look at a smaller frame, uh, not the large frame, and also requires retransmission of smaller frames in case of error. So instead of retransmitting the larger frame, the source can only send the smaller frame if there is an error in the frame. And this uh, fragmentation of the frame also prevents a station from occupying the medium for a long period, because it is easier to transmit smaller frames compared to the larger frames. So but then the stop and wait flow control becomes inadequate for multiple smaller packets per message in a high quality link such as LAN, because it has to keep on waiting for the acknowledgement back from the destination or the receiver. So that will be the waste of the resource. So instead of having this stop and wait flow control, there is another mechanism called the sliding window flow control. This sliding window, it allows multiple frames to be in transit, which means a source can send multiple frames before it is being acknowledged. So the receiver has a buffer of size W, so it can store W number of frames. All right, so the transmitter can send up to W frames without getting acknowledgement back from the receiver. So a transmitter can send W frames without getting the acknowledgement back from the receiver. So it's not like it has to keep on waiting for the acknowledgement back from the receiver for every frame. It can if it has multiple frames, which is less than or equals to W frames, then it can send all those frames without waiting for the acknowledgement back from the receiver. So how it sends is like each frame is numbered with a sequence number, and then the and then the um, and then the receiver will send the acknowledgement back to the source with a number of the next expected frame. All right, so the sequence number is bounded by the field of size k in this sliding window. So frames are numbered modulo 2 to the power k, and then the maximum window size uh, up to 2 to the power k minus 1 in this sliding window. So how does this sliding window function? So in this sliding window, at the sender, the upper one is depicting the sender's perspective, and then the lower figure is depicting the receiver's perspective. At the sender, this is showing the uh, frames that is already being transmitted. So you can see this vertical bar, the one on the left re representing the um, frames that are already being acknowledged. All right, and then on the right, and these frames 6 and 7, these are also being transmitted, but these are not acknowledged yet. All right, and then the one with the blue shaded region, these are the uh, frames that the sender can send, and these blue shaded region, it represents the buffer size. All right, so the window of the frames that may be transmitted. All right, so if the source is going to send to the destination, let's say it is sending the frame 0, then it is going to shrink. This region is going to get smaller. All these numbers are representing the frame that the source is transmitting. All right, so let's say it has already transmitted 7, right? And then if it wants to send another frame, yes, it can send another frame, which is the frame 0. And then when it sends that frame 0, this window size is going to shrink. So it's gonna slide to the right. And then if the frame 6 is acknowledged by the mm, receiver, in that case, this vertical bar will shift to here, and this region will slide to the right. It will expand again. All right. So as the receiver is sending the acknowledgement, this is going to this vertical bar is going to uh, move to the right, and then also this window is going to slide to the right. So that's why the mechanism is known as sliding window. So here, like, it has the window size of 7, uh, buffer size of 7, right? Because it can send, it has already transmitted 2 frames, 6 and 7, which are yet to be acknowledged, and then it has the capacity to send 5 more frames, 5 more frames. So uh, so it can transmit these frames without waiting for acknowledgement back from the uh, receiver. And then upon receiving the acknowledgement, uh, it can again expand further. At the receiving end, what it does is this is representing the frames that it has already acknowledged, and then these are the frames 6 and 7 are the frames that it has received, but it has not acknowledged yet. All right, and these are these 0, 1, 2, 3, and 4 are the frames that the receiver can uh, store. It has a buffer space for storing these frames if the source has some data to send. All right, so the windows of frames that may be accepted is represented by this shaded blue region. And then when the receiver it acknowledges these frames, this vertical bar will move to the right, and then this window is going to span to the right, like, so it goes. So if this vertical bar moves to here at the end of 7 before 0, then if there is no data being sent from the um, source, then this window is going to expand till 6. And this is how the sliding window works. To understand this further, let's look at this example. Let's say a source system A wants to send to the destination system B. So here the window size is 7 from frame 0 to frame 6. So Let's say a source A is sending frame 0, frame 1, and frame 2. All right. So as it has already sent 3 frames, the window size it shrinks, and then it has this window size from frame 3 to frame 6. Here, like 0, 1, and 2, it is not shaded and is on the right hand side of this vertical bar, which means these frames are being transmitted but has not been acknowledged by the uh, receiver. So once received, uh, once these frames are received, the uh, destination will also have the window size accordingly. And then after that, if it has like processed it, and if it is okay, then it is going to send RR3, which means ready to receive the third frame. So the receiver, it sends this RR3 message to the source. So once it is received, the window size is again expanded. So it goes up to 7, 0, and 1 as well, again. So the window size is again 7. So which means uh, source A can send 7 frames without receiving any acknowledgement back from the receiver. So after that the frame it wants to send is the frame 3, uh, and then also the source is going to send, like if it is sending frame 4, 5, and 6, what happens is, so after receiving the frame 3, the source it acknowledges the frame 3 and then sends the RR4, which means ready to receive 4. So after receiving the frame 3, and this vertical bar moves to here, right, from 2 to 3, end of the 3, and then which means it can receive 4, 5, 6, 7, 0, 1, and 2. And then at this point it hasn't received the frame 4. So after it sends this, it is going to receive frame 4, 5, and 6 as well. And then once it is received, it will set the sliding window as shown in here. So 4, 5, and 6 are received. So it can potentially receive 7, 0, 1, and 2 if source has these frames to send. So what happens like after, now let's look at what happens when the receiver sends this RR4. So by the time by the time the source receives this RR4, it has already sent this uh, frame 3, 4, 5, and 6. So initially this vertical bar was here, but then it received this RR4, which means destination already acknowledged for the third frame that was being transmitted. So this vertical bar moves to here, and here like 4, 5, and 6, because destination hasn't acknowledged to these frames, and it can potentially send 7, 0, 1, and 2 frames if it has uh, any frames to send. So this is how the sliding window operates. So in addition, there can be enhancement in the sliding window by implementing this RNR, which means receive not ready. So what it means is like the receiver can acknowledge frames without permitting further transmission from the source. So that will help the receiver to um, stop the sender to send any further frames. So in that case, the sender will not be able to send any frames further. And then in order for the sender to send any frames, it needs to receive the normal acknowledgement from the receiver. And then if the transmission is duplex, can use the piggybacking, which means if there is no data to send, use acknowledgement frame. And if there is data but no acknowledgement to send, send the last acknowledgement number again, or have acknowledgement valid flag as in the TCP. So this is all about the frame transmission models with error-free, and the transmission model with errors and losses, and the different flow control mechanisms to overcome those, which are stop and wait flow control and sliding window flow control. I hope you guys enjoyed this video. Thanks for watching.